And my answer is x is 1/2. Okay, this one looks a little weird, but think about it. If you had a 4, you can change that 4 to a 2 squared. And I could change this 9 to a 3 squared. So the way I'm going to write that so it makes more sense is I have 2 to the 2/3 squared equals 2/3 to the x power. So I can cancel those common bases. What you see left is x equals 2, and that is my final answer. So this next one looks weird again. We can deal with a 16. We probably have done that a couple times already. That 16, that 1/16 is really 1 over 2 to the 4th. But remember, we're going to keep just common bases. We don't want to change the 2 to a fraction, so we're going to write this as 2 to the -4th. Now, I kind of forgot or just didn't write that 3x that's still out there with it equals 2. Don't forget also, if there's just a base with no numbers, there's an invisible 1 there. So I do have a common base, so I can cancel those 2's. Now, when I see what's left over here, it's a little bit more. So what I'm going to do is I'm going to take this -4 times that 3x. So -4 times 3x is a -12x equals on the other side a 1. Divide both sides by -12. When I do that, these -12's cancel, and you get x equals -1/12 as your answer. Okay, over here, it looks like a little bit of a mess because there's that crazy 1/5 right there. But to get rid of that, I can multiply both sides by 5. When I do that, these 5's right here cancel, and then I'm left with a 1, which is fine. So I'm left with 5 to the 2x minus 1 power equals 25 times 5 is 125. Now we need to change it to a same base. So if you think about 125, I can change that to 5 to the 3rd. And then I'm going to just leave this one the way it is. So when you have your common base, you can cancel those 5's. What's left may be a little longer, but it's still what's left of your problem. And we'll be left with 2x minus 1 equals 3. So let's go ahead and add 1 on both sides. And I'd be left with 2x equals, those 1's cancel. That would be a 4 because 3 plus 1 is 4. Divide both sides by 2, which I totally don't have room for, and you'd have x is 2. Okay. Now, we learned how to write a radical as a fraction. Remember, there's an invisible 1 right there and an invisible 2. So technically, that is 9 to the 1/2 power. Now, you still have that x up there, so I need to write that. Equals. Now, I know that 9 squared is 81. So I'm able to get my common base already, which is marking out those 9's, and then what's left is 1/2 x equals 2. Let's multiply both sides by 2. These 2's cancel, and there's your x by itself. And 2 times 2 is 4. This one looks a little scary, but 10's are pretty easy if you think about them. 10 to the, how many zeros do I have? 3. So 10 to the 3rd equals 10 to the x minus 1. So I already have a common base, so mark those bases out. What I have left is what I've got to create into a problem, which becomes 3 equals x minus 1. I'm going to go ahead and add 1 on both sides and get 4 equals x, or x equals 4. This one looks a little scary, but this is the tens place, this is the hundreds place, so technically that is 1 over 100. Well, we don't want that crazy fraction, so we don't want to change that to a fraction. So really, 1 over 100 is 1 over 10 squared. And because I had to drop it, it's really 10 to the negative 2 power. And I'm going to go ahead and bring down the equal and the 10x. I have the same base, mark out those tens. What's left is this negative 2 and that x, and that is going to be my answer. X equals negative 2. Okay, this one, last one. So let's get rid of that 1/2 first. So let's multiply both sides by 2. When I do that, these 2's cancel, and I'm left with 32. 2x minus 1 is the power, equals 1 times 2, which is 2. Well, 32, you can change. 32, I can go all the way to 2 to the 5th. Keep what I already had up there, and we're just going to put it in a parenthesis. And then bring down your equals 2. And don't forget, there is a 1 right there. Okay? So when I go to cancel out these common bases, what's left is a little bit longer, but that's okay. So I am going to first, I'm going to distribute this. 5 times 2x is 10x. 5 times negative 1 is a negative 5. And on the other side, you still have that 1. So here we go. Add 5 on both sides. And now you have 10x, these cancel, equals 1 plus 5 is 6. Divide both sides by 10. These 10's cancel, and you get x equals, well, I can reduce both of these by 2. So 2 will go into 6 3 times. 2 will go into 10 5, and there's your answer. And that's the last problem in these notes.